In this video, I'm going to give you a chance to calculate the mean and standard deviation. So we have kind of a real-world situation where there's a contractor and he bids on the jobs that he's interested in. And we're going to let X be the number of jobs he receives in a month. And X is a random variable. He can't predict with any certainty how many bids he's going to win. And so let's just say past experience shows that the probabilities here are that X is either 1, 2, 3, or 4 jobs, and these are the corresponding probabilities. One thing I was going to say is when we do probability by taking the number of outcomes in an event divided by the total number of outcomes in the sample space, that is known as classical probability. And you can use that in situations where you can actually determine how many outcomes are in the sample space. But if you notice, in this situation, it's not possible to know exactly how many outcomes there are in the sample space and then how many outcomes are in your event. So what you would do is you would take past records and you would actually find the percentage of months where you had 1 job, 2 jobs, 3 jobs, 4 jobs, so on. And then you would use those past percentages to as your best estimate of what the probability is. And you're just kind of assuming that if things continue as they were in the past, these are what the probabilities would be. And when you do that sort of thing, that's called empirical probability as opposed to classical probability. So in a sense, that's what we're doing here. And so now what I want you to do is I want you to calculate the mean and standard deviation of X. Just like we did in the last video, but now it's your turn to do it. So go ahead, press pause. When you're done, you can start back up again and see how you did. Okay, so now let's see how you did here. So the mean here is just each value times its probability. So it would look like that. And we can put this in my calculator. So 1 times 0.2 plus 2 times 0.3 plus 3 times 0.4 plus 4 times 0.1. And when I do that, it looks like I get a probability of 2.4. Okay, so that's my mean. Okay, so now let's find the standard deviation. So now for the standard deviation, I take each value and square it and multiply it by its probability. And I do that for all the values. Okay, and now we got to remember we're not done yet. Okay, I then need to take the mean and square it. Okay, and so I need to take all of this, subtract the mean squared, and then I take the standard deviation. Okay, so let's do this. So if I do 1 times 0.2, I just get 0.2 plus 4 times 0.3 plus 9 times 0.4. So I'm squaring them here. Plus 16 times 0.1. And when I do all that, I get like 6.6. So that's this portion right here. And then when I do 2.4 squared, that's 5.76. And then I take the square root of that. So now 6.6 minus 5.76. And I get like 0.84. And the 0.84 is actually the variance right there. And then I take the square root of that to get the standard deviation. And it looks like I get 0.9. And again, I'm rounding to the tenths place in either case because my variable is actually to the ones place. And so I'm rounding these to the tenths place. So there's one other comment I want to make, and that is that oftentimes the mean of the random variable. Oftentimes this is called the expected value of the random variable. Okay? It's, in this case, it's like the expected value of x. And the reason for that is x is the number of jobs he receives in a month. So when you calculate the mean, he can expect to have about 2.4 jobs per month. Now, of course, he'll either have, 1, 2, 3, or 4 jobs, not 2.4 jobs. But when you average it out, balance it out, taking into account the weights here, the probability, then it actually averages out to about 2.4. And so on average, he's expected to have 2.4 jobs per month, and they would call that the expected value. Okay? And then this, of course, is the standard deviation. So he would expect to have 2.4 jobs, give or take, 0.9 for the standard deviation. There you go. That's calculating the mean and standard deviation of a random variable.